So for this last video, we're going to review just potential energy and then go over example problem number 26 and go over some equations. So first thing we'll do is review Newton's law of gravitation, which is Fg equals Gm r squared. So now we're also going to review equations for potential energy. So potential energy equals potential energy equals negative derivative of F dt. So, and then our final equation that we'll go over is the equation U, potential energy, equals Gm m over R. So you should write those equations down quickly, and then we'll get on to the next part, which is the practice problem. So for practice problem number 26, here it's the third and final part of the three-part problem. So we can look at the diagram. Two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speeds v1 and v2 as shown in the figure above. Their orbital radii are r1 and r2 respectively. Assume that the mass of the planet in the middle is greater than m2, which is greater than m1. So now we're going to look at our specific problem, which is if U1 is the potential energy of the planet-satellite system containing the satellite of mass m1, and U2 is the potential energy of the planet-satellite system containing the satellite m2, which of the following expressions best represents the ratio U1 over U2? So now what we're going to do is we're going to look back to our equation that we learned, which is U, potential energy, equals G over m times m over r. And this is m r and this is m satellite. Okay. So first we'll write out potential energy of m1. So we can write U1, and that'll be GMR times m of satellite 1. So it's going to be the inner satellite, as we can see on our picture. And then that'll be divided by R1, which is the radius from the satellite here to the center. And then we'll do the same for U2, which is potential energy 2, which is G times MR times mass of satellite 2, which is on the outer orbit, and it's going to be divided by R2, which is the radius for this. So over R2. Sorry, that was supposed to be R1. I don't know why. So that, as you can see, R1 is for M, this inner satellite. So now what we're going to do is the problem just asks U1 over U2. So all we have to do is divide these. So GM R MS1 over R1 over GM R MS2 over R2. And then we'll see that we can cancel out the GMR. So how you do a fraction like this is A over B over C over D equals AD over BC. So what we're going to do here is it's going to be M satellite 1 times the bottom, all the way on the bottom, times R2 is divided by the two things left in the middle. So MS2, mass of satellite 2 times radius of satellite 1. So that's going to be our answer. So we can look in here. M1 R2 over M2 times R1. And that's what we have here, so our answer is going to be C.